Hello, everyone. My name is Chris Switek. I'm the Chief of Product at ICVR.
Hi, and I'm Hierarchical. I'm CEO at ICVR.
And today we want to talk about the concept of a golden data set and also best practices for structuring your Unreal Engine data for AI training and also other useful things. Just a little background about us at ICVR. We're a content production studio that specializes in Unreal Engine, and we make games as well as non-game, interactive, and linear content. Internally, we have a heavy focus on engineering. Like with our IC Tools division, which is what we're going to be talking about today, which focuses on licensing tools and professional services for Unreal Engine production. This is our third year giving a talk at Unreal Fest. The last 2 years, we shared information about our licensed UE pipeline, and our latest focus has been ensuring that the data that we can collect through these tools can be used to build this concept of the golden data set. So this is really important to us and has kind of been our passion for the last 12 months. We're also official service partners with Epic and Perforce. We help studios who are switching to real-time or looking to build tools. So we'll start here with a quote by Larry Ellison, who is the CTO of Oracle. And he said in an interview recently that unless you have your data properly organized, you can't use AI. It becomes utterly useless. And although he said this partially to promote the Oracle database, in general, we agree with the sentiment of this quote. Maybe AI doesn't become utterly useless, but at the same time, it becomes much, much less powerful if you don't have your data in order. So that's what we'll be talking about today. We'll be looking at what is a golden data set in the context of Unreal production, why it's important, what do you need to track in order to achieve it, and how we can solve some of the common issues that are standing in the way right now. And just to preface, this talk is framed around using Unreal for linear animation and cinematics, just in the examples that we give, but most of this also directly applies to games or any other piece of UE content creation as well. So what is a golden data set? A golden data set is a curated collection of high-quality data used to train, validate, and test AI models. And when it comes to Unreal production, the data from your production that you can collect is the gold. And much like the golden idol in Indiana Jones, it can sometimes be elusive and difficult to capture this data, and you have to work in order to do so. So that's what we're going to be going through.
So what makes the data set golden? And we built the strategy around 4 key pillars. That the data need to be high quality. The output quality of any model really depends on the data quality input. The data need to be diverse, and you need to have a larger sample size of it. The second is the data needs to be complete. So as much as you can track across the versioning, the context, and of all of the assets, that's the key. And internally, we say that the strategy is to basically track everything. Consistency, it's the third pillar, that uniform formatting and labeling of data is extremely important. And last but not least, it's the accuracy of the data. And that your data, which you store in the golden data sets, need to be free of errors. Like Chris said before this talk, it's not about what AI can do today or what's going to do in the future, but how to prepare yourself for it. But from just direct practical production benefits, we see these areas on the acceleration of production, that today there are already a large number of AI tools which can help your artists to, for example, create 3D assets or 2D assets, automatically rig or animate inside of different DC packages. It can empower your artists by removing repetitive tasks. So some of the good examples which we use in production is the AI-assisted texture creation for assets. make smarter production decisions, help your producers to better analyze the projects, spend less time on creating constant reports, and basically get deeper analytics and insights on your project. And the quality control and auto-fix of the issues. And it can go from the asset creation to the engineers as well, like writing like unit tests using LLMs.
So before we get into it, let's look at a little example of why this data can be valuable. And one of the biggest reasons because of that is that AI models require validation. If I have an AI image generation model, for example, that's designed to generate pictures of cats, then I need to be able to look at the outputs from that model and tell it whether it's correct or not. So the image on the left, that's a great looking cat. Image on the right, not so much, right? So we need to be able to tell the model whether it's right or wrong, and then it can use that information to improve. And in the early days of AI, and even still, fairly often now, this validation is and was done by humans. I could take thousands of outputs of pictures of cats from my cat model and feed it into a service like Amazon Mechanical Turk and get answers back. And much like the device that this was named after, which was a chess-playing robot from the 1700s, it wasn't actually mechanical. There was a little guy who hid inside and controlled the robot. But to outside observers, it looked like it was mechanical. But nowadays, you truly can train models mechanically. You can use one AI model to train another one. But that process becomes a lot harder if you're looking at something complex like a UV map for a 3D character, for example. An average person can look at a picture of a cat and say this is or is not a cat, but an average person can't do that with a UV map. And then if you want to try to train it with another model, you have kind of a chicken and an egg problem, right? If you want to use another model to validate whether this is right or wrong, how do you train that other model and validate that other model as well? But imagine if you have a golden data set of past production data from multiple productions that includes every version of every UV map that you've created from one or more projects. And some of them, if they had mistakes, then have a task associated with them that describes the issue. And then you have a final output fixed version with everything corrected. So you can see here, this is what a UV map should and should not look like. And then you have data which can be used to validate your model. And now I've kind of simplified this a little bit for example. So if you're an AI PhD, don't pick me apart in the Q&A. But this does show one of the many ways that this production data can be valuable.
And also, we want to mention, as a preface to this talk, that right now as an industry, we are in this a little bit legal gray area of use of AI, and specifically around the data ownership. One of the ways you can mitigate this, it's by injecting metadata and creating the traces of ownership around your assets on which you train the models. And as well, whenever you use any off-the-shelf models, verify the ownership on that. And even if you're not training your own models, today a lot of tools allow you fine-tuning and refinement of the models. And that's where like your own data set can be crucial because you can have the stylistic control and guidance around that. For example, like we're showing here, we can use off-the-shelf stable diffusion and to generate with a prompt an image. But you can feed it your own data set to guide it into the look and feel of how you want it to be. But for fine-tuning and refinement, there one part which is currently widely available. It's the stylistic control of the assets, where you can basically configure your style and feel of the outputs. But one of the areas which is currently being overlooked or not touched enough by the industry as a whole is the technical control of the output. For example, like if you take the poly count, models which are trained on VFX quality models might have problems to be used for real time, depends on how the night goes. But also like on deeper level, like material and material slot count and similar, or just as a file format output, it can be very problematic. And in general, if you don't have technical control over the generated assets, it can actually create you more overheads and give you benefits for your production. And also, don't forget about, again, your producers and what today LLMs give you for your data and analytics. Because, like I was saying before, with integrating the data from your production tracking and from other sources, you can basically get much better insights with them, but also you can embed the predictive estimation and predictive resource planning, like we show here. Like you have thousands and thousands of assets created within your studio with time tracked against it or estimates. So whenever you're bidding on a new project or estimating a new project, you can easily map out how much time it's going to take to build new asset.
And as I said before, it's not just about AI, right? There's other benefits that this sort of data set can give to you. And one of the biggest ones is when it comes to asset reusability, right? If I want to reuse an asset, I need to know where it is, I need to know what that asset is, and then I need to know if I can work with it or not. And if you can accomplish all of those things, then success. You can reuse your assets. And the things that enable that is, number one, asset traceability. So being able to track through your data set where every version of every asset is located on storage across different types of storage, whether it be production data or something like Perforce. You also need to have contextual metadata and tracking. You need to know what each asset is, and you need to be able to search for it and ensure searchability. And then you need to know whether you can actually work with it or not. Number one, from just a legal and usage rights perspective, right? Do I have the rights to reuse this for this new project? And then you also need to know if you can work with it from a technical standpoint. Is this asset compatible with the current version of the software that I'm using right now? And one of the keys to that too, and to enable flexibility in editing of assets, is preserving working files, right? If I'm modeling something in Maya, I don't just want the FBX output of that. I want to retain the Maya project that it was built in. And same for other DCCs that you may be using. And one example of this from our pipeline is our asset loader. We use this information to power it. You can browse your asset library, import the right files into whatever DCC you're using. If you're in Unreal, you can import as UAsset. Otherwise, if you're in Maya, you can have a Maya-compatible format. And one of the biggest takeaways that we want to get across with this presentation today is also the importance of starting to build this data set now. Even if you're not currently using AI in production or even planning on using it in the near future, you should not assume that all your data can be properly converted to the proper structure later on. It's difficult to convert legacy assets, especially if there's no standardization. And also, oftentimes, there's just an incredible amount of manual work required to do this, whether it be pulling it off drives or cold storage, exporting, importing, tagging those assets. So if you can do it along the way, it's critical. And then on top of that, a lot of data is just missing. Things like that context and metadata and working files. And if context is not recorded during production, it's nearly impossible to add it later, or at least without an incredible amount of manual work. So it's essential to future-proof your data. And the earlier that you start to do that, the more valuable your data will become over time.
And pretty much, will you capture it or basically get crushed by a boulder?
Don't get crushed by a boulder. Okay. So how should this data be structured from a technical perspective? So let's take a look at that. And for this example, we're just going to look at an Unreal Engine scene. This is a shot that contains a set with a house at the highest level. And then we're going to track the asset storage structure all the way down to the most granular level, which would be a sub-asset of this house, and then even components on that sub-asset. So before we talk about that too, I think it's important to acknowledge some of the difficulties about tracking data in Unreal especially. And one of the big ones there just comes from the fact that some of the most important assets that you're working with in Unreal are binary files, like levels or sequences. And it's impossible to merge or diff those files using traditional methods like you could do with text human-readable code. So this means in order to have a complete picture of what's in your level or sequence, you have to track that additional context and metadata. In general, it's kind of similar to the same concept as USD, right? But our goal is to try to apply this to the native UE outliner and include support for UE native assets, things like the binary files, blueprints, et cetera. So the way that our pipeline is structured uses hierarchical manifests to track everything that's going on within the project. We start general, and we get more specific as we go down. And this is probably the general hierarchical structure that many of you are used to. We start with our scene. We move on to shot. From there, we go on to set. Then we have the assets contained within that set. We have sub-assets of whatever asset we were looking at before. Then we have representations of those assets. We have variants of those assets. And then finally, at the lowest level, different instances of those assets that we all need to be able to track. Most people do a great job of tracking things like scene and shot and asset. But the problem is when you get to that black box area and you start trying to granularly track what's inside of Unreal. So we'll look at that here. And we'll follow this graph to the end and kind of look at it piece by piece to see what it's composed of. So this is the way we track things, and it also kind of represents the database structure that we use to track them as well. Within each, so we consider every one of these an asset. A scene is an asset, a shot is an asset, a set is an asset. And within the manifest for each one of these assets, for all of them, we have this basic scene information. That includes things like the unique identifier of that asset. It includes the name of the asset. It includes the type of asset that it is, as well as the version of the asset. It links to a task, so you can associate a task with that asset and see things like pipeline step or the amount of time that it took to create it. And then publish data, so who published it and when. And then underneath that, we have a complete list of sub-assets. Everything that this asset contains. So a scene, for example, will contain a list of shots as sub-assets. So if we follow that down to shot, shots have the same basic info. We don't need to go over that again. And then we have a list of the sub-assets that a shot contains. These are things like animation, characters, effects, lighting, even the storyboard for that shot. And for this example, we'll follow down into set. So we consider our set here to be like our neighborhood that our house exists in. And here, once again, we have a list of sub-assets. These are the items in your set. And here we also will start talking about representations, which is a really critical component of the way that we track these assets. And representations essentially are just all the different forms that the asset exists in. So for a set, one of the representations would be in Unreal, which is basically the master level of your scene. And then we also have things like a Maya project representation or an FBX representation that's been exported out of Maya. And we know where all of these things are on storage, and we do the same versioning for each one of these. And we do that for every asset all the way down. So we'll follow this set down into a specific asset that it contains, which is a house. And then once again, our house contains sub-assets. A house is made up of doors and windows and walls, etc. And then under this list of sub-assets, or under this list of sub-assets, we can follow one of those down and dig into that. So a sub-asset of a house, for example, would be a window. Once again, we have our representations of that window. We have our static mesh within Unreal Engine. And then we also link to our other representations of this window, whether that be the Maya project, the Substance Painter project that it was surfaced in, FBX, and even the concept art. And then within this asset, we can track all the different variants of that asset. So within this one house, within our scene, we might have some windows that are open and some windows that are closed, two variants of that window. We can follow down, in this case, our closed window asset, and then we get down to the different instances at the lowest level of that asset. So let's say we have two different closed windows on that house. And for the lowest level representation of each one of these assets, we also record positional data, things like XYZ and scale and rotation. And then we can also track components within those assets. So that's really important if you're using things like packed level actors, right? Where it's not all in the outliner, but it's still important to know what's inside of that asset. We can do that with things like blueprints as well. And based on that, we also track material instances, which is super important for things like asset reusability. Just having the U asset without the material is kind of useless. So knowing what those dependencies are and where they are is super important. And then with that, we have a complete set of data on everything that's in our scene, down to the lowest level that we want to track. You may not always want to track the components of an asset. So why is it important to granularly track this stuff, right? That's a lot of data over a lot of production. And number one is that type of granularity comes in really important with AI training. You want to be able to understand how to generate assets in a modular way that's compatible with Unreal level design and outliner hierarchy. And it also allows you to have an understanding of something as a collection of multiple subassets. So instead of thinking about the concept of a house as just one big rigid thing, now you can think about a house as a collection of subassets like doors and windows, et cetera. You can also use tasks that you're tracking to associate those tasks with specific parts of a house. So if you have a task for an artist to model that window, you can now see how long it took to make that specific part of a much larger asset. It's also important with asset reusability, like I mentioned earlier. Being able to easily detect and retrieve dependencies is really important. And ability to just work with UE native and specific assets like blueprints and your binary files. And one huge thing that this allows is it can allow you to actually perform diffs and merges for binary assets. So if you can't do that by comparing the actual file itself, you can compare the manifests for version 2 of a scene and version 3 of a scene. And if you want to roll back a specific part, instead of having to go back and rebuild that, you can just perform that merge based on the objects that you place within the scene. And that's one of the reasons that it's important to track things like the positional data, so you know where to put it if you want to move something. It also helps with security and access control, safeguarding sensitive data, and just knowing what you can work with for the future. These assets within the scene, maybe these are Quixel assets. Maybe these assets within the scene are associated with a specific IP. Or maybe you have proprietary blueprint tools that you can also tag in this way. So if you want to try to reuse the scene later on or share it, you can make sure those things are stripped out.
And what's make it difficult is to be able to track this data and across various data sources. In reality, you have your production data would live in the task tracking and asset tracking. You will have your files actually will be living across your source control or your production storage like NAS or similar. Then you have your pipelining tools would be generating various metadata types within the DCC packages. And you have additional, like Chris was mentioned, the access and rights management tools or digital asset management, etc. And from there, it kind of creates a multitude of problems which we see throughout productions. And so what's missing? And it's kind of from bigger picture, we think that a lot of productions today have the data left in the, like for example, the production tracking softwares like ShotGrid or Jira, and the data stays there just during the production. After the production is spun out, this data is being lost. The lack of access and rights management creates problems in the future to track the ownership of the assets and actually the level of to be able to control the access on the reusability of these assets. If you go deeper into the production data, also like we were shown before, and Chris was saying that a lot of productions today track oftentimes on the either task level, asset level, shot, etc. But what is critical is to granularly track the versions of the sub-assets and specifically the dependencies. Because a lot of the assets today inside of Unreal have combined materials and can have VFX or rigs attached to them. And all of these files have different representations and different versions which live across production. Ability to track within your source control as well which change list attached to which representation. And the last but not least, it's to be able track the metadata within the files which come externally from your studio. For example, either from vendors or if you buy assets from Fab or similar Unreal marketplace and bring it inside of your pipeline. A lot of times the metadata is non-existent or lost. And from file storage, a lot of problems which we see across productions which we participate in. We don't see in many cases uniformity in the file naming conventions, in the formatting, and a lot of times it also differs within same studios between project to project. And to solve this problem, at minimum, you can keep a unified index across board that you're able to normalize the data after the case. And the lifetime tracking of the assets, that they survive, the data and the assets survived after the production is spun down, that you can reuse it and move forward with it.
So these are kind of our big roadblocks that Igor was talking about here. The things that most commonly stand in the way of achieving this concept of the golden data set. And to address this, we have kind of like a 5-part philosophy that we would recommend in order to make sure you can fix these issues. And number 1 is to establish a single source of truth for all production data, not just necessarily your Unreal data, which you would do through source control. It's also important to bridge the data gaps that Igor was talking about. There's multiple ways to do that depending on what the issue is. Number 3 is letting tools and automations do the heavy lifting. A lot of this data recording can just be done automatically at regular intervals throughout the production. To plan for the complete data lifecycle, as you were saying. And last but not least, to not try to boil the ocean, right? Try to do everything at once is incredibly overwhelming, so you can stick to the important stuff. So what do we mean by a single source of truth in the concept of the golden data set? Most people are familiar with that in reference to source control, right? Source control acts as the single source of truth for your Unreal Engine data and your project, but it's not designed to track things like production data, like you would do in ShotGrid, or tasks, like you would do in something like Jira or Handsoft. Also, it's difficult to look at the granular contents of binary files inside of that black box, like we talked about as well. So why not just use ShotGrid or F-Track or another production software for this? Primarily, they're good at what they do, which is designed to track shots, right? But we want to track a lot more than that. They're also not as flexible or fast compared to what something like an enterprise-level database can do with high volumes of data. And if you're really committing to building this golden data set, you will have massive volumes of data. They also don't have a flexible branching system or way to like non-linearly merge assets or database entries. And finally, just one of the biggest problems is if that is going to be where your most important data is stored, then you become reliant on a third-party solution. You have to make sure you keep active licenses, and it's difficult to switch away in the future if you want to move, for example, from ShockGrid to FTrack, or who knows what will come out 10 years from now. So the solution to this is to set up an abstracted database, a database that is completely separate from ShockGrid and everything else, but integrated with those services. So you can still use ShockGrid as a front-end tool and work there in the way that you're used to. But when you make changes with ShockGrid, that will actually sync to the database, and then vice versa if you need to change something from the other end. And this database can persist between projects. It allows complete ownership of the data, more power and control over how the data is structured, and also just flexibility with working with whatever software solutions emerge in the future within the industry.
And to bridge these data gaps, in a nutshell, it's these 4 points. Where we all need to keep, you need to keep the naming conventions as consistent as possible. And I want to just acknowledge as well that it's extremely hard to keep unified naming convention across different project types. For example, like a cinematic versus episodic animation versus a game project would have different structure and different requirements. And it's okay. The main goal of it is to keep a record of your naming convention for a specific project. If you have unified index, then you can always normalize after that the data when you archiving it or need to be reusing it. The ability to have a granular asset manifest, which would break down the necessary metadata and go into the black box of the binary files. And integration between all of the services, which we talked previously, to unify the metadata into one place and have it tracked against the necessary assets or code base. And ability to have a structured automated ingest process for whenever you have your vendors or freelancers publishing data to you, or if you ingest into the pipeline external assets purchased on third-party stores. And we think that you need to let the tools and automations do the heavy lifting. So in this diagram, internally, we showing our process where basically, if we start to do like our gray boxing or early level designs inside of Unreal, on the step 1, when the level design artist completes the tasks, they publish in the data where under the publish, they export the block out into the FBX or similar interchange format. The publish data is being recorded into database with all of the metadata attached to it, and also updates in the task. At the same time, you record the task context against this data. Then it would go, for example, into Maya for modeling and UV, where you pretty much would create a new representation on the second publish step of a working Maya project, have the export of the FBX as a new version in app, and record all of the metadata and update the task. And you repeat on step 3 when you do the texturing and export all of the textures to go back to Unreal. And besides planning just for the asset lifecycle, which I was talking in the previous slide, one of the main strategies that we implement internally and advising to everyone, it's implement for the full data lifecycle as well. Because overhauls of the systems can be like extremely costly and time-consuming. And I think a lot of us have been in the industry for long enough to live through custom engines and switching between them. But the main goal right now is how can we ensure the scalability of the systems? And we are trying, we're making sure to design our systems in a modular way and thinking ahead, how can we upgrade or change the different components of the system as we go along. We building strategies and considerations around how the data volume and complexity are gonna grow, because the data demand can change between different departments and different needs. Implementing the archival procedure across and protocols on the projects. And the main thing, it's not only have the archival process at the end of the project, because to be honest, I don't think a lot of us have just time for that after project is wrapped and we move into the next one. But having the archival processes and with standardized metadata processes created during the production in each step of the process. And having the protocols and data management systems scaled across the studio and not just within one individual project. Kind of thinking how it would grow across all of the studios and be unified.
And last, once again, don't try to boil the ocean here, especially if you're starting out, right? It's better to focus on the important parts and start tracking that now, better than to take on like a 3-year mega project where you end up tracking nothing throughout those 3 years, right? So get started small, quick, and fast, and just build from there. Yeah, so that's basically it. This philosophy is what we've built our IC Tools pipeline around. And a lot of the upgrades that we've been working on for the past year have been designed to achieve this. So this topic is close to our heart. Our pipeline is pre-built and we license it out. So if anyone is also passionate about this, like we are, we're always happy to talk more and chat. So please feel free to reach out. Thank you, everyone.
Thank you.